Multi-cloud and MoM conundrum. The 5G revolution and the tower operator dilemma. 5G is the next big thing, as these headlines show. Big players are putting billions of dollars to dominate. The United States government is treating it as a national priority with its own requirements for equal access and rural deployment. Many who have seen IT technologies such as storage area networks, hyper-convergent infrastructure, virtual machines, and associated complexity, are wondering if this too is a hype or reality. 4G or 5G, what is the big deal? With the current pandemic, we have discovered how to communicate, collaborate, and conduct commerce at the speed of light with our cellular devices, currently limited by 4G. 5G promises faster access to information anywhere, serves order of magnitude more customers, and will connect many different types of devices. Connecting things and people with each other and to businesses provides a new opportunity for all kinds of services, such as drones using 5G and deliver goods in rural areas, and autonomous vehicles become autopoietic, self-managing, by connecting with local environment. 5G to connect people and things to each other, and to the businesses is a complex task. As the picture shows, it involves three equally important, but siloed industries bringing together a solution. Big players with their billions of dollars are trying to dominate without an end-to-end solution management with complex schemes, and the tower operators are caught in the middle trying to sort things out. While everyone is trying to own the end-to-end service delivery, operation, and management directly connecting with the end user or the device, the complexity of dealing with multiple service providers with multiple technologies is becoming complex and costly. For example, how many subscriptions the end user has to pay to see a movie when all it is needed is to ask the network to connect to a movie at the cheapest price with fastest delivery. In addition, security and data governance are becoming key issues that current internet architecture falls short in solving. This picture is self-explanatory, showing the tower operator thrust in the middle without the expertise to deal with the complexity. Some of the tower operators are mom and pop shops who were leasing the antenna space for telcos and other operators deploying their electronics. As we will see in the next slide, they are undergoing business model disruption and need new strategy. Even the big tower operators are caught in the disruption and are looking for new opportunities to survive. In addition, capital-starved telcos are divesting their towers, which makes 5G deployment that much more complex. First, the merger of Sprint and T-Mobile is causing loss of revenue to the tower operators. Second, new competitors are putting pressure on their revenue. Third, 5G densification, small antennas and device-to-device direct communication are causing tower operators to search for new strategies. Fortunately, the tower has a well-kept secret capability, namely the space, to deploy an edge cloud that is emerging as a new opportunity for connecting things and EOPL and managing the connections in the face of fluctuations in the demand for services or the availability of computing resources. In addition to the tower operator predicament, we also have the complexity increasing with the multi-cloud architecture, and the complexity of 5G service electronics deployment and management evolving as silos. Cloud brings unlimited scalability and serverless automation. When edge computing meets required service levels, it is cheaper and faster. However, managing thousands of heterogeneous devices, and hundreds of applications for millions of users at the edge, is problem number one. Dispatching workloads in real time either to the edge, or towards clouds when needed is problem number two. The small video depicts the cloud bottleneck. Delivery of access, electronics, and services. All the three pillars address both functional requirements and non-functional requirements. Functional requirements are driven by business goals that define the software. Non-functional requirements address the security, availability, data governance, placement of computing structures and performance of the software during its execution. Problem: choose between 1. End-to-end information service delivery and operation made complex with multi-vendor, multi-cloud solutions, or 2. Be dominated by single vendors owning the end user with siloed products and technologies. Here are the requirements for workload deployment, to manage end-to-end information service that deal with scale, resiliency, and efficiency. Scale deals with hundreds of distributed service delivery points, thousands of services, millions of users, billions of devices. Resiliency deals with non-stop service availability, hacker-proof security, global and local data governance, application SLA assurance. Efficiency deals with end-to-end service visibility and control, workload placement to optimize efficiency, vendor agnostic and infrastructure agnostic service delivery and operation. The evolution of computing structures, it is evident that various technologies reach their limitations with respect to scale, resiliency and efficiency. Workloads are computing structures assembled from computing functions in executable form, and they need enough resources, CPU, memory, latency, bandwidth, storage capacity, throughput, and input and output operations per second, in a distributed environment. As long as there are enough resources, the workloads evolve in an equilibrium. However, fluctuations in workload demand or availability of resources cause disequilibria. The time it takes to readjust the resources depends on the size and nature of fluctuations. Reconfiguring physical infrastructure is slower than reconfiguring virtual machines and IP address-based network structures. As scale, and distribution, and resiliency and efficiency requirements become large to support communication, collaboration, and conducting commerce at the speed of light, current network architecture breaks down, as shown as the complexity cliff in the picture. The cliff can be overcome by a new architecture that George Gilder so eloquently describes in his book Life After Google. A detailed discussion of the shortfall of current Internet and potential alternative based on sentient computing, which is based on new mathematics and is different from Gilder's blockchain economy, is discussed in the videos, and you can access it through this link shown here. Architecture with sentient computing consists of hierarchical intelligence to place workloads where they are optimal, when they are needed and are infrastructure agnostic, autopoiesis. Hierarchical intelligence to monitor workloads and their health and reconfigure the workload structure to address fluctuations in non-functional requirement fulfillment, homeostasis. End-to-end workload visibility and control with cognizing agents in real time to optimize their availability, performance, security, and governance. Workload management blueprint.